Hello. Today we will simplify the following expression where x and a are real numbers. At this point, I would recommend to stop the video and try to solve the problem yourself. After this, please share your answer with us using comments section, and when you return, we will continue work together. First, we will repeat some properties of logarithm, which we will use today. First is just definition of logarithm. According to definition, argument of x equal a to power y. Then we know that a is positive and not equal to 1, and argument x is positive. Other properties are the following. First, we have that log a of 1 equals 0 for all possible values of base, and log a of x equal 1 over log x of a, because x here is a base, x not equal to 1. Now we will find admissible values of x and a for our expression. We denote this expression as a for convenience, and recollect the restrictions on x and a which follows from definition of logarithm. Additional restrictions can come from existence of square roots here, but we see that both logarithms here are positive, so the radicand here is non-negative. For this reason, these square roots don't give us new restrictions for x and a, and we can start transformation of our expression. We consider first a radicand. We denote it as a1. It is equal to this expression. We replace first a logarithm as this, and the second we transform to this form. Then we replace log x of a using this property. Then we rewrite this expression in the following form and plug in both these answers to the expression for a1. We can see that these three terms can be represented as a square of this sum, and this gives us the answer for a1. Now we can return to a and consider the radicand for this square root. It is equal to square root of a1 plus 2, and let's find square root of a1. Both these logarithms are positive, so we can eliminate modulus. So we have here this expression. Now we calculate square root of a1 plus 2. And again we see that here we have a full square, but now of this expression. Now we can find a. It is equal to this square root, or this one. This is equal modulus of this expression. So we plug in this answer here, and we have for a the following answer. It is more simple than original, but we can continue simplification. We consider this modulus, denote it as m. M is equal to this expression. And now we should understand how we can eliminate sign of modulus. First, we find a and x, which provides positive value for the logarithm. To do this, we recollect the plots of a logarithm for different a. If a is greater than 1, we have here this curve, and for a less than 1, we have this plot. For the first case, a greater than 1, logarithm is positive in this area, so for a greater than 1, x greater than 1. For the case a less than 1, logarithm is positive here. It means that we have second range for a and x, which is given by these two inequalities. In this case, logarithm is greater than 0, and we can write that m is equal just the sum here. We again use the transformation of logarithms and rewrite this equation in this form, plug in here, and we see we will have 0. So for these ranges of a and x, our expression equals 0. Now we consider second case, when a logarithm is less than 0. For case a greater than 1, this happens here. So for a greater than 1, x from 0 to 1. For a lesser than 1, it happens here. So logarithm is negative here. So for x greater than 1. So in these two ranges, expression for m has the following form, or it is equal just this. We plug in this expression here, and have here the answer for a. So we considered two necessary cases, and now we can write the answer. So our expression is equal 0 for this a and x, or equal to this expression for a and x given here. The problem is solved. If you have different solution or different answers, please let us know through comments section, and we will discuss this later. And finally, let's help Dr. B in his future work on the new videos. This help can be done as likes or dislikes, subscription, or positive or negative comments. Thank you for your help.